Okay, so thank you to the people who sent me an email just asking me to go through questions 4 and questions 5. I think these are definitely worth going through, and there's a lot of learning that we can do with these questions. So if I look for a second at the question 4, it says find the value of x and find the value of y correct to one decimal place. If I look properly, you will see that we are dealing with, overall, we're dealing with this type of triangle here, which to me looks a little bit like a scaling triangle because it doesn't look like isosceles or a right angle triangle. Now, if we are at Junior Cert and we are asked to find the length of a side or a length of an angle in a triangle, we can only do it if it is a right angle triangle, which basically means in this triangle here, I need to separate this into right angle triangles because none of my sine, cos and tan works with a scaling triangle. It only works with right angle triangles. So if you look here, this one here, triangle 1, that's a right angle triangle. And if I was to look here with triangle 2, that's a right angle triangle. And so I'm going to have to split them up and work on them individually. Okay, so you can see I've drawn here my 2 triangles. I'm going to fill in everything that I know. So this is obviously my right angle triangles here. I know that in this first triangle here, this is x, this is 3, and then this angle here is 53 degrees. And then in the second triangle, I have x again, y, and 27 degrees. So you might ask me, well, which one do I start with, miss? Like, which one do I start with? So if we examine this triangle here, I know an angle and a side, and I'm looking for another side. So I have 2 bits of information, and I'm looking for 1 bit of information here. But in this triangle, I have an angle, but I don't know 2 sides. So obviously, in everything, in maths, if you only don't know one thing, it's a lot easier than if you don't know 2 things. So we're going to start off with this. Always start off with the one that you have the most information about. Okay? So I'm going to zoom in on this triangle here, and I'm given a right angle triangle, and I'm given an angle, I'm given a side, and I'm asked to find another side. So if I'm given angles, I know I can use my trigonomic function here. So I'm going to start off by following my simple steps. So number 1, and hopefully you know them at this stage, is label your triangle. So this is my right angle, so I'm going to write a little bit, maybe in purple I'll write today. So this one is my hypotenuse. This is my angle, therefore this is my opposite, and then this is the one that's left, so that's my adjacent. So step 1 is label. Step 2, we might write down our trig functions. So sine, cos and tan. So sine, and I should really say the sine of the angle, the cos of the angle, and remember I'm just using theta as notation for angle, equals, okay. Oh hell, another hour of algebra. Okay, so let's look at what I have here. I've been given my A, so I'm happy with my A. And what do I want to know? Do I want to know my H or do I want to know my O? I want to know my O. So it's A and O is the ones I'm going to look for. And I'm spotting here that it's going to be tan. So I have my A and I'm looking for my O and my angle. So step 3 then, let's fill in the function as we know for the trig function. So we have tan of theta equals O over A. So now that becomes tan of, well, what is theta? Theta is the angle, and the angle in this question is 53 degrees. So 53 degrees equals O, which is opposite, which is x, we don't know what that is, all over A, which is 3. So that is the hard bit done. Remember, we want x on one side, everything else on the other. But what I can do here is I can figure out what tan of 53 degrees is. And I can actually just do that by typing that into my calculator. So your calculator's at the ready now. Type that in, see what you get. Okay, and I'm getting 1.327 equals x divided by 3. I would like x on one side, everything else on the other. I'd love to get rid of this divide by 3. How do I get rid of a divide by 3? I multiply by 3. But what I do to one side, I must do to the other. So that will give me the divide by 3 and the multiply by 3 cancel. And on this side, I get x. And on this other side here, I have 1.327 multiplied by 3, which gives me 3.981. And I think this question says to 1 decimal place. So if I was to keep that to 1 decimal place, the correct answer here would be x is equal to 4.0. Okay, so now I can move on to my second triangle, okay? And I can fill in the new bit of information. So instead of having an x here, I know now x is, I figured it out, x is 4. Could also sub it in here as well. So I now know x is 4. And I'm working on this triangle here, where I'm given a side and an angle, and I'm asked to find another side, but it's a right angle triangle. And so I can follow my 3 steps here, labeling, putting in my trig functions, figuring out which one I want, fill in what I know, and solve for the unknown. So that's why we spend so long labeling these triangles, because if we don't get this bit right, everything else falls apart. So right opposite my right angle, I have my hypotenuse. Right opposite my angle, I have my opposite. And then my last one is my adjacent. Okay, we're looking for y here. So we're looking for the a. And the only other piece of information I'm given is the o. So a and o is what I'm looking for. So it's tan again. So it's tan of the angle equals o over a. So now it's going to be tan of 27 degrees equals 4 over a, and we can call it a or we can call it y. I'm going to call it y just to. So again, we want y on one side, everything else on the other. And you can fill out a little bit, and I want you to finish it off, because from here to there you should be able to do, and the final answer here is y equals 7.9. So well done if you did well on that question, if you got it out. And if you didn't, just have a look. Remember what I said about when we're doing sine, cos and tan, it has to be a right angle triangle. So it's super important we split these triangles and work on them separately. And this is quite a common aspect of this, you know, recognising the basics and solving to finish. Okay, question 5 then was very similar to this. And so I'm going to just straight away split it into my 2 triangles, because we can only deal with right angle triangles. So on this first one, I'm told this is 45 degrees, this is y, this is 4. And then obviously y is common side in both. So we have a y in this triangle, a 12 and an a. So again, we always start off with the triangle that we know the most about. So in this one, I have an angle and a side, and I'm looking for another side. And in this one, I have a side, and I'm looking for an angle and a side. So you can see there's 2 bits of information I don't know here. There's only 1 bit of information I don't know here. So obviously we start with this one here. So if that's the case, I'm going to label appropriately. So this is my h, this is my opposite, and this is my adjacent. Okay. So in this question here, I am given my opposite, I'm given my adjacent, and I'm looking for my opposite. So that is tan of the angle. So let's fill in what we know. What is the angle in this question? The angle is 45 degrees equals the opposite. We don't know what that is, so it's y. All over the adjacent, we do know what that is, which is 4. Now, we want y on one side, everything else on the other, but we can actually tidy this up a lot. So tan of 45 degrees. When you type that into your calculator, what are you going to get? So tan of 45 degrees is what we call a special angle. And it's unusual because when you type in tan to the 45 degrees, you actually just get 1. So here we have 1 equals y over 4. I want y on one side, everything else on the other. So it's a divide by 4 on this side. I'm going to multiply by 4 on this side. They will cancel, and you're getting y equals 4 here. So that helps us now with this next part, because I'm now going to just redraw that angle, and I'm going to call that 4. So you can see here, Now we have two sides and we're looking for an angle. So like everything, step one is always to label. So I've got my hypotenuse, I have my opposite, and I have my adjacent. Now, we can see here that what we're actually looking for is the angle, okay? So we have the opposite and the adjacent. So we're going to use that, the opposite and the adjacent. So we have tan of the angle equals opposite over adjacent. Tan of A, because we don't know what that angle is. So in this case, we could write tan of 45 because we knew the angle was 45. This case, we don't know. So tan of A equals, but fill in what we do know. The opposite is 4 and the adjacent is 12. Now, what am I looking to find here? What is my unknown? Hopefully you're saying your unknown is A. You want A on one side, everything else on the other. Now, how do I get rid of a tan? So we met this in the video, in the previous video. You can only get rid of a tan if you do a tan to the -1, because then they'll cancel. But you know, in balancing, from the very minute we started learning algebra, what you do to one side, you must do to the other. So tan to the -1 has to go here as well. So we can now change or tidy that up a little bit. So normally we write A equals, and we actually put this first. So we say tan to the -1 times 4 over 12. And if you type that into your calculator and you do it perfectly, you should get 18 degrees. And so we've actually found from this question, we know that the length of this line here is 4, and we know that the angle here is 18 degrees. So lots of learning in that, and hopefully you didn't go too far wrong.